Welcome everybody out to podcast number 394. Are you implementing Whacky-Takty? Stay with us.
This is the Elevate Construction Podcast, delivering remarkable content for workers, leaders, and companies in construction wanting to take their next step. Get ready to step out of your comfort zone with Jason Schroeder as he encourages you to do better, live a remarkable life, and expect more. Let's go.
Welcome everybody. I hope you're doing well. This is going to be a fun little podcast, but it's going to be really, really packed with good information, new information, probably stuff you haven't heard before. The other thing that we're going to cover is Goodhart's law. So we're going to pack it full right now. Let's get going. So Whacky-Takty, this is something that we kind of coined the term on in Germany. And it was because we were thinking about the possible failure to implement Takt in the right way. And we actually saw this in one location. Most of the time in our trip, we saw really, really great world-class examples of flow and pull in one facility, which I won't tell you about, meaning I won't tell you where it came from. We saw an example of what we call Whacky-Takty. It's kind of in line with the if you've ever heard of Whacky-Taffy or Whacky-Tacky, there's some really fun little candy that I used to eat when I was a kid that was kind of goofy and weird and just off the beaten path a little bit, and it was a little bit whacked and kind of out there. And so I've seen and would fear in the future to see some Whacky-Takty plan implementation that's just kind of out there. So that's what we're going to talk about today, because there are ways to get this wrong. And so we're going to have that. So that's what we're going to cover. Before we do that, I want to insert a little, a little section about Goodhart's law. And what this law says is that, well, actually, let me just read it to you. So, Goodhart's law is an adage named after British economist Charles Goodhart, who advanced the idea in a 1975 article on monetary policy in the United Kingdom. Problems of monetary management, the UK experience. Any observed statistical regularity will tend to collapse once pressure is placed upon it for control purposes. So, in a paper published in 1997, anthropologist Marilyn Strathern generalized Goodhart's law beyond statistics and control to evaluation more broadly. The phrase commonly referred to as Goodhart's law comes from Strathern's paper, not from any of Goodhart's writings. And this is what it is. When a measure becomes a target, it ceases to be a good measure. One way in which this can occur is individuals trying to anticipate the effect of a policy and then taking actions after altering its course and outcome. And so let's stick with this one sentence. When a measure becomes a target, it ceases to be a good measure. And so I've seen this before when we're talking about production, KPIs, measurements for safety and quality. This is really what I'm talking about is embodied in this example. So first of all, let's talk about what is a KPI. A KPI is a quantifiable measure used to evaluate the success of an organization, employee, etc., in meeting objectives for performance. A target is a measurement, state, or condition that indicates a predetermined goal has been reached. So what this law is essentially saying is that KPIs become useless when the KPIs also become targets. And so let me talk about that just for a minute. If you have a production goal and you want to measure this as a key performance indicator, and you make a goal out of that key performance indicator, maybe on a scale of what, on that KPI scale, you say 10 of a certain something is our target. Well, it stops being an indicator once it becomes a target, because once the target is reached, then human beings will typically stop. And so I like the Japanese concept of perfection is the goal. Perfect will have to do. Perfect is the only standard. And are we getting better each day, better than the next? because once we set a target, then typically people will stop. It becomes a thermostat, meaning if you set a thermostat to 76 degrees and the temperature gets higher, right, it will regulate back. And so if you have a KPI and then you set a target along that KPI and you go past that KPI to really wild success, it will thermostat back to the target. I saw this one time where when you're doing production tracking and the production target is reached, foremen, workers, superintendents, project teams will stop once the target is reached, even though they could make more money. And so it thermostats them to a certain level and below because there's always variation. And so I like that concept in Goodhart's law. And let me go back to it, that when a measure becomes a target, it ceases to be a good measure. So that wasn't long enough to have it be its own podcast. I did quite a bit of research on this and I was like, I don't know if this is an entire podcast. So I wanted to plug that in here. The bottom line is we always have to plan for variation and we have to keep going in a lean concept towards perfection, total participation, and we have to keep going to where we understand that we're better every day than we were the day before. And so I hope you enjoyed that. But what we're really talking about today is Whacky-Takty. And so I really like the title there. It's hard to say. It's kind of funny. But let me do a little bit of scaffolding before we get going. So if you have any podcast topics you want covered, please let me know. If you have any questions, I would love to answer them or find somebody who knows the answer. If you have any feedback, please give it to me. I absolutely love feedback. And please remember that this podcast is for you. It's all about love. It's about getting the information out there. And this really is a training podcast. So we need to know on a pull level what training is needed. So if you ever have a question, please let me know. You ever want to attend a boot camp for any project management position or any certification training that we have, please let me know. So what am I excited about in life? I'm excited about online course material. We're working with Niklas Modig and his company's operational excellence and construction excellence to start recording, and it's pretty remarkable actually, start recording videos on an online learning series that can be sold throughout the world. And it's really, really exciting. They'll obviously be in English, but they can be accessed anywhere, and it's on one of the best platforms in the best approaches, training approaches that I've ever seen in my life. So let me talk about some fans and feedback. This actually came from a human being in person, and this is what he said. You have become the voice of what I've been trying to say for years. And this person told me that he made his entire company start listening to the podcast. And it was like, hey, team, this is where we're going. And so I thought that was a really neat compliment that somebody would think that I have become the voice for what they've been trying to say. So I really, really, really appreciated that. So let me tell you a story. Getting into this topic, the conflict is we're still using tacted systems to push, and we have to stop this practice. And so let's go ahead and tell you a story. I was in a manufacturing facility and we were looking at the operations. And there were areas of excess inventory and there was a lot of waste, people moving around, and things just seemed to be off rhythm. And what we found out is that there were some bottlenecks. And I've talked to you about this before. There were some bottlenecks in the system and there weren't pull systems, meaning when one piece of equipment was completed, they weren't automatically pulling or creating pull throughout the system. Each piece of equipment, each station was still pushing material and inventory onto the next system because they were attempting to keep up with the takt time. And I want to be really clear about something. That is not the way we do things. In takted systems, we finish on time for one purpose and one purpose alone. And I want to tell you what that is right now. It's because takted systems create capacity and they create buffers. And those buffers allow us to pause the system and pull the andon or the andon or however you want to pronounce it, and stop the system and absorb the variation. CPM systems do not allow that because they create a critical path, a string of activities where if any one of them are delayed, it delays the whole system. Last Planner can create buffers in the system. Scrum creates capacity and buffers in the system. And Takt really creates buffers, meaning days that can absorb variation in the system. And so when I do Takt trainings and I'm like, we need to stick to a Takt time, people are like, oh, so you've always finished? You've never had variation? I'm like, no, heck no. My systems or my projects are just as prone to variation as yours are. It's just that my system with Takt is that I have created buffers within that system so that I can absorb that variation. And you cannot ever have a schedule. And I want owners, I want superintendents, I want company owners, I want everybody, foremen, to hear me on this. The most idiotic thing that we could do in construction, the most idiotic, stupid thing that we could do is to create schedules without buffers, to create schedules that can't absorb variation. Every single schedule should have buffers in the system to absorb variation. And this is one of the things that I've been thinking about lately about Takt, and the message behind Takt is that it's the only system that allows you to pause when you find a problem. And so let me talk about that really quickly. I've been reading the Toyota production system Beyond Large Scale Production by Taiichi Ohno. And he talks about the two pillars of the Toyota production system. One of them is just in time, that everything has flow and pull. And the other one is automation. When you think about automation with a human touch, what that means is that you have a system, you have a systematic flow, but when there are defects, automatically you can stop the line. Humans can stop the line. The human touch can stop the line. The system will find the defects. Now, when it happens in a production line, just like then this is in Toyota or BMW or wherever, you can stop the line. You can pull the andon. You can pull a cord, push a button, whatever, and stop the entire line together. But what happens in construction is if we have a delay in one area, typically we just let that area get out of sequence and we keep pushing everybody else, and then everybody gets out of rhythm. And when you get out of the rhythm, you've entered a push situation. And so what we need to do is understand that the key to their success was that the entire system stopped. So first of all, they had flow. When they didn't have flow, they had pull. Pull meaning that one area only produced whatever items that they could produce when another system was ready for it or had need for it. It was a pull system. It wasn't a push system. And in a tacted system, if you keep that takt time going, regardless of whether or not one of your areas or whether one of your trades or whether one of your machines is keeping up with that pace or not, if you keep pushing everybody according to that takt time, then you are going to have push, excess inventory, all of the 8 wastes, overburden, and unevenness. And that's going to throw your system out of production, out of line, out of efficiency, and you won't have flow efficiency. And so what I'm saying is, in summary, the best thing that you can do is have a schedule where if there's a major problem, and not something small that they can recover from, but a major problem, you can stop the entire tacted system and eat into one of those buffers and have everybody stay at the same pace, the same distance apart, and allow everybody on the project site to pause. Now, most of the time, people are going to say, Jason, you're crazy. This is the dumbest idea I've ever had. But when you have major impacts, that's what you're going to have to do. If you have a big problem with concrete, you're going to have to pause the entire concrete system. If you have a major problem with interiors, you're going to need to pause the entire interiors production system. If you have same thing with anything. But if you let one area or one trade get disconnected, then you're going to overproduce before that scope or that trade or that area, and you're going to create variation and workers waiting on work after that area or that scope or that trade. And it's going to create ripples of variation throughout the system. If you're in a factory, just like we observed in this factory, If you attempt to keep everybody on the takt time, even though there's an interruption and you don't pause the system, then you'll have 10 machines overproducing, one trying to catch up, and all of the machines after it waiting with workers waiting on work. But you could pause everybody, and here's the kicker. Allow everybody in the system, everybody throughout that project, everybody in that manufacturing plant, everybody to basically prepare for their quality work the next time. This is the key to takt planning. When you pause the system, everybody doesn't just sit around twirling their thumbs. They do these things. They make sure that prior activities are completed. They make sure construction and design information is ready. They make sure materials and components are prepared. They make sure that workers are trained and ready to go, that equipment is maintained and ready to go, that the workspace is safe, ready, and clean, and that any other approvals and permissions are given. They make sure that materials are queued up and stacked and ready to go. They make sure that they do training with their employees. They clean their stations. That is the genius of a tacted system. Is that within our cycle times, if we get done early, we prepare the next task instead of moving it forward. If there's an interruption in the system and we have to enter a buffer, we don't keep pushing everybody and moving things forward. We pause and we prepare the next activity so it can hit right on the rhythm. That a tacted system, just one more time, has a rhythm, and it has flow and it has pull. And when there's major variation, we pause the system. We pause the schedule, and we allow for that interruption to be absorbed into a buffer, and we keep everybody the same distance apart, going the same speed, not overproducing, and we allow everybody to get back onto rhythm, and we spend our time in that pause preparing for work, again doing those key things which are called the 7 conditions for a sound activity. Prior activities, finishing as you go, quality at the source, any design information and preparations, materials and components stacked, ready, prepared for the work, 100% ready to go, workers trained, oriented, extra training done, equipment maintained and ready to go, the workspace is clean, safe, and organized, laid out, and any approvals and permissions are given, and that we are finishing as we go with limited work in process, quality at the source, and we're making sure 100% that we're doing it in the right batch sizes according to the right takt time. So Whacky-Takty is where you have a rhythm, and even if there's an interruption, you keep pushing everybody through it, which causes overproduction, which causes waste, which causes unevenness, which causes overburden, and it will interrupt and create variation in the system. But normal takt planning is where you create an optimized schedule with buffers, and those buffers allow you to pause the system or stop the entire project of work or the entire phase of work and say, we all are going to pause for a minute, get this problem fixed. We're going to eat into a buffer day. We're all going to make sure that we're staying on that same rhythm, and we're going to make sure that we have the capacity to absorb this variation together, and so that we don't create a scenario of push. And so I hope I've explained this the proper way, because this is a really, really impactful scenario. So let me just give you one example. If you're working in a phase and you have a 2-day delay in an interiors, and you want to keep everybody on a takt time, right? And you have a 3-day takt time, and every 3 days that drum beats, but you get let's say light fixtures are missing and you have a real big problem. Do you then create a pause and eat into a 3-day buffer with one of your takt times and let the electrician catch up, give everybody else an additional 3 days for their deadlines, allow them to spend their time preparing and get everybody back on sequence according to the beat? Or will you just let that one area with that one trade, with the electrician, with their light fixtures, basically slow down, keep everybody going at full speed with their deadlines, and cause a ripple throughout the system, which is hard to recover? When you're in a manufacturing plant and you have a takt time and you have one area that has slowed down for some reason, are you going to keep all the machines overproducing even though the whole system needs to pause? You know, flow is a superior system to pull. We first flow, then pull, and we never push. But if you are flowing with a tacted system and you have an interruption, and if you don't pause, you will be pushing. So remember, flow where you can, pull when you can't, and stop pushing. And you can get into a Whacky-Takty kind of situation if you use tacted systems where you don't pause and eat into your buffers when there's a problem. So at a minimum, I need you to please consider this concept because it's pretty powerful. Where are you on your projects or your manufacturing floor or in your company using a tacted system where you're still pushing and where you haven't created buffers, where you don't have buffers in the system, and you're actually using the tacted system like a push system and not a flow system? Are you using it like a push system instead of a pull system? Are you stopping to fix problems as you go and stopping the entire system together so that all of the trades can stay the same distance apart and go the same speed? Because, and I'll leave you with this, hopefully you understand, or no, not that you understand, but that I've explained it well enough. When people say, Jason, why have you always finished projects on time with Takt? The answer is because I always have buffers and I always stop the system and I always fix things as we go and I always keep the trades the same distance apart going the same speed because I have buffers and CPM does not. On we go.
Please join us next time in elevating the entire construction experience for workers, leaders, and companies coast to coast. If you're enjoying the show, please feel free to share with your construction colleagues and help us spread the word by rating, subscribing, and leaving a review on your preferred podcast listening platform. We really appreciate it. We'll catch you next time on the Elevate Construction Podcast.